Welcome to the module on dyeing process. I am Dr.N Gunavathy, Assistant Professor and Head, Department of Chemistry, Nirmala College for Women, Coimbatore. This module on dyeing process gives a basic understanding of the types and the sequences involved in a dyeing process. Let us understand about dyes. Substances used to impart color to textiles, paper, leather, and other materials such that the coloring is not readily altered by washing, heat, light, or other factors to which the material is likely to be exposed is known as a dye. Both dyes and pigments are colored because they absorb only some wavelength of visible light. However, they differ from each other. Dyes are colored substances that chemically bond to the substrate to which it is being applied. Mostly, they are organic compounds. Pigments, on the other hand, do not chemically bind to the material they color, and they are finely ground solids dispersed in a liquid. They can be organic compounds or inorganic compounds and give brighter colors than dyes. Dyeing process. The application and fixing of a dye to a substrate, normally with the intention of obtaining an even distribution throughout the substrate, is known as dyeing process. Types of dyes. Dyes can be classified as fiber dyeing, yarn dyeing, and fabric dyeing. Fabric dyings are further classified as woven dyeing and knit dyeing. Now let us understand fiber to fabric through yarn. Twist several strands of fibers to make a yarn, and twisting several yarns together gives us a fabric. Dyeing can be done at any stage of fiber to fabric. So, fibers can also be dyed, or they can be converted to yarn before dyeing. Also, after knitting them into fabric, they can be dyed. The sequential processes involved in dyeing process are: the gay fabric are subjected to inspection and stitching, followed by shearing and cropping, sizing, desizing, scoring, bleaching, drying, mercerizing, dyeing or printing, followed by soaping and drying, and the finished goods can be folded and packed. The sequential arrangement differ based on the type of the dyeing process. These are the various machines that are used in different types of dyeing process. Now let us see the various steps involved in yarn dyeing. In yarn dyeing, the grey yarns are inspected and then they are wound softly, bashed and loaded into the machines for scoring, bleaching and then dyeing. Hydro extraction is done to remove the excess of the solvents, and then they are dried, hard wounded and subjected to final inspection before the goods are delivered. The steps involved in a woven dyeing process are: the grey fabric inspection is done, followed by stitching, brushing, sizing, desizing, scoring, bleaching. After bleaching, it can be subjected to mercerizing or it can be subjected to printing followed by dyeing of the color to the fabric, and then the finished good can be subjected to final inspection before delivering the goods. In the case of knit dyeing process, the steps involved are gray fabric inspection, batching, sizing, mercerizing, scoring, bleaching, dyeing. After bleaching, either it can be subjected to printing or after dyeing the goods, it can be subjected to printing process. The finished goods are subjected to final inspection before the goods are delivered. These are some of the machines that are used for knit dyeing processes. The various machines that are used during the various steps of dyeing are knitting, dyeing, the dryers, tube text compacting, the laboratory for testing the final goods, then sewing, finishing and printing. The successive stages of dyeing or the mechanism of dyeing are: the dye or the chemical substance is first dispersed in the dye bath, which diffuses and then forms an electrical double layer on the fabric, or it can be said that it is getting absorbed on the fabric and gets diffused into the fiber. Bond formation between the dye and fiber takes place, imparting color on the fiber. The dyes used in dyeing processes can be classified as based on the method of application as direct dye, reactive dye, vat dye, azoic dye, sulfur dye, basic dye, acid dye, dispersed dye, etc. Based on the chemical structure, they can be classified as azo dye, indigo dye, anthraquinone dyes, polymethanine dyes, sterile dyes, nitro dye, nitroso dye, phthalocyanine dye, aryl carbonium dyes. Apart from the coloring substances, certain auxiliaries and chemicals are required for dyeing and finishing of the fabrics. So some of the auxiliary chemicals used are wetting agent, detergent, sesquewriting agents, leveling agents, anti-foaming agent, dispersing agent, anti-greasing agents and carriers. Depending upon the requirement, one or all these auxiliary substances can be used. Application of dye. Dye can be applied directly as a dye liquor by spraying or by foam application or by printing. Another method of application is the continuous immersion of the fabric in a dye bath and the removal of excess of liquor by the squeezing or suction, also called as a padding process. The processes can be classified as follows: continuous dyeing process, which can either be a pad dyeing process or a pad steaming process; semi-continuous process, which can be classified as pad batch process and pad jig process, or it can be a discontinuous process which involves winch, jet and jigger. It can also be a pad dyeing process as pad roll processes. The further classification can be as mass dyeing, where dyeing of a synthetic polymer is done before the fiber formation takes place. Pigment dyeing, affixing an insoluble colorant on the fiber surface with a binder. And exhaustion dyeing is dyeing from an aqueous bath with a dyeing that has an affinity for the fiber. There are various parameters that involve or affect the dyeing process. First one is a liquor ration which involves the dye solubility and strength of the electrolyte effect. Lower liquor rates are employed whenever possible for ecological, economic and technical reasons. Electrolyte is another parameter. For example, sodium chloride or sodium sulfate, its concentration and the speed of addition control the absorptive behavior of the dyes and the degree of exhaustion. A high electrolyte content of the bath shifts the dyeing equilibrium towards the fiber. pH values influences solubility substantivity of the dyes and their stability in the dye bath. However, pH values improve exhaustion. However, levels proceeds preferably at higher pH values. Temperature generally determines the position of the dyeing equilibrium, which at a room temperature is shifted strongly towards absorption on the fiber. So dyeing technology, goal of every dyeing is a colored textile in a desired shade, homogeneous in hue and depth of shade, produced by an economic process and which exhibits a satisfactory fastness property in the finished state. Hope this module given and knowledge or insight into the various steps of dyeing process. Thank you.